Hey there, hermanos, Alejandro, and welcome back for day 127 of me doing the NeetCode 150 challenge. So today we're doing our very last LeetCode Medium Math and Geometry problem, and without further ado, let's get straight into it. Okay, today we get a LeetCode Medium problem 2013, Detect Squares. You're given a stream of points on the XY plane. Design an algorithm that adds new points from the stream into a data structure. Duplicate points are allowed and should be treated as different points. Given a query point, counts the number of ways to choose 3 points from the data structure such that 3 points in the query point form an axis-aligned square with positive area. An axis-aligned square is a square whose edges are all the same length and are either parallel or perpendicular to the x and y axis. How could you get a square that isn't? I guess it's like diagonal, okay. 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 Implement the Detect Squares class. Add. Count. Count the number of ways to form axis-aligned squares with point equals xy as described as above. So what you want, essentially, like, okay, I can do this trivially too, right? Also, why does a point can be duplicated? What? Why? Holy crap. Okay, what is this? Ah, because it can form it with either of these. Right, right. Right, okay. 1,000, eh? Also, I can do no, can I do n squared? At most 3,000 calls will be made in total to add and count. Count. No, I can't make it cubic, right? Okay, I need to do this in an efficient type of way. Okay, I need to do this in an efficient... Okay, so like a square is defined. There's probably going to be something sus about the fact that it's things on the same x or y plane, right? Yeah. Maybe it's look at like every pair that are in the same row and column as a point. And essentially, you always have 3 points, so you know where the fourth one should be. Right, because you're querying off a point anyways. Right, because the naive way is essentially like, you know, looking at every other point, treating that as the opposite corner and being like, do I have the other 2 corners that I need? Versus looking at things only in your row or column. But by doing it the other point way, it just might make things technically faster. Not asymptotically, but like practically faster to do things by things that are in the same row or column index. Because like my intuition would tell me to do something like this, right? Self dot d is equal to dict event, right? Point to frequency mappings. And then here we'll do self.d of, we're given points as, yeah, so we'll do tuple point plus or equal to 1. Here we'll do for other points in self.d. Here we'll just make this a dictionary. right? X comma y equals point equals tuple point. So dot d of point equals delta d dot get point comes 0 plus 1. Yep. In self.t, we'll do if equals other points. Continue. Otherwise, here we'll say, okay, treat point and other point as corners of a square. Right? So if we have x1, y1, point x, point y, x comma y, continue. We could call this x1, y1, and so on. Res equals, I wish is there something like, okay, I'm going to whip up my terminal here. This was from a previous question. If I do import, because here I can't do product, right? But is there like import func tools? Can I do func tools dot product? No. Import iter tools, is that what it's called? Iter tools dot product of 1, 2, 3, 4, 5. Oh, this probably does something else, right? Is it related to combinatorics? Yeah, okay. Yeah, okay, I don't know how to do product. Okay, no worries, no worries, no worries. Self.d of res times or equal to self.d of comma y res times or equal to the d of x comma y of point x comma y res times or equal to self.d of x comma point of y, right? And then like return res. What about something like this? Yep, so we definitely need a column there. Okay, okay. Yeah. Dot get 0 dot get comma 0. Okay, so that's accepted. Let's submit. Is this too slow? Wrong answer. Okay. Oh boy. Oh boy. Okay. Okay, how about we just don't have that continue in there for now? That doesn't really matter. Wait. Oh, I want to sum things. What am I doing? 0. Here I want to do res plus or equal to this, because this is just for a specific other point, times this, right? Yeah, okay. Sorry, I'm being completely dumb here. Okay. I'm failing more stuff. This is going to be a little bit more annoying to debug here. Okay, first of all, let me get rid of something like that. Doesn't really matter much. Well, here I have an overestimate. Oh, because I'm gonna get to the same point-ish again? Is that why? Ah. Right, because if I get to point X and Y, visited is equal to set. If X comma Y in visited, continue. Visited dot add X comma Y, visited dot add point of X comma Y, visited dot add X comma point of Y. This might not even be enough, right? Because here I might need to check all three. If point X visited, continue. If X comma point Y visited, continue. Not quite. Let's see. No. Okay. Okay, this is a toughie. This is a toughie. We could also do, yeah, is this like read heavy or write heavy? Either case, I'm gonna have to do like accounting, right? I could add the, it depends on if I do more adds or counts. I want to do ideally whatever's cheaper. Yeah. Yeah, it's gonna be something like this, right? If and equals self.d of X comma Y, something like that, so that way whenever I get to each one I only sum each thing. Not quite. Hmm. This is interesting, right? Because you can usually think of squares as just two diagonal points. Or is this where the axis aligned stuff comes in? Also, yeah, here I'm not even getting the right side. Yeah, let's just get rid of visited stuff. Now it's still wrong, really. Interesting. Dex squares class. Yeah, this is interesting. Very interesting. Thank you. It is not immediately obvious how to solve. Into a data structure, duplicate points are allowed and should be treated as different points. Given a query point, counts the number of ways to choose 3 points from the data structure. You could also just do it by row points and column points. Every such pair. But I like that less, right? Because now you're looking at pairs of points, because in the worst case, you're actually going to make things worse. I do like the idea of going through the points in this way. It's just I got to think, right? When I have a point, a diagonal point, right? Maybe I can do something like unvisited set of self.d.keys, right? And then here's like unvisited dot remove point x point y, and then here's like while length of unvisited is greater than 0, x comma y equals visited dot pop res plus or equal to point 1 point 2 equals x comma point y point x comma y. Here what we should do is unvisited dot discard unvisited dot discard y. Okay, this should be unvisited dot discard point x comma y. Res plus or equal to self dot d of xy. Point x comma y comma 0 times self dot d dot get x comma point y comma 0, right? Turn res, something like this. Oh, the point they give you doesn't necessarily have to be in the dictionary. Interesting. That's insane news. Okay. Still wrong, eh? How is this wrong? Oh, it has to be of, no, but these are all, oh, it has to be a square, right? It has to be a square. Um, only append to res if it's square and not a rectangle. Maybe that's why we're getting overestimates, right? We need to make squares. Which means if absolute value of x minus point x doesn't equal to absolute value of y minus point y, then continue. That's what I'm missing, right? Yeah, okay. Now submit. Yeah, there we go. Okay, first accept the solution. Yeah, we have to make sure that they're actually squares and not rectangles. Ah, that's silly. That's pretty funny though. Okay, but now we don't have to do things in this way and so on. So yeah, we just need to make sure that things are squares. Okay, I'll actually put this comment. Yeah. Okay. And now we'll yeah. If absolute value of x minus y, of x minus point x doesn't equal absolute value of y minus point y, then continue. Right? Then otherwise, yeah, now we might be overcounting for different reasons. Yeah, because of the, yeah. Because it equals set. Well, first of all, we can have this. Oh, okay, that's it. Is that all I needed? Just this? Just do your own point. Yeah, nice. Nice. If this is the case, then we can do this. There we go. Turn res. Get rid of all this complicated logic over here. Nice. Let's run this one more time. There you go. Let's submit. And there you go. Bada bing, bada boom. We're kind of in this standard deviation curve, so there might be a more efficient way of going about things. Maybe we could put some of the logic inside of add. I don't see, like, you know, the benefit in, like, looping through the points whenever you add so that it becomes O of 1 whenever you count, right? Because it's just like, it's going to be, I guess if you do it via add, you only do it once via an add, right? And then it's like you can call count as many times as you want. So maybe it's better to do things inside of add. Could be possible. But then adding becomes very expensive, right? And if they just spam a bunch of ads, that's like it's inefficient. So like you're gonna have to do it in counter. It's gonna depend on whether there's more counts than ads, right? It could be that if I do the logic inside of add, it'll be faster and so on because maybe they have way more count operations than add and so on. So like, you know, if this was an interview, then I would ask, like, you know, is this application gonna be more add heavy or more count heavy, right? Because then it's like you can put the load more inside of one than the other, right? Kind of a thing. But without knowing any knowledge, right, you can't do much, right? Is there any follow-ups here? Yeah, like 3,000 calls in total will be made to add and count, but you don't know how much of each, right? So it's like it's kind of hard to tell. So okay, nevertheless, as always in all my videos, I do a quick recap of how I was able to solve the problem. So for this one, essentially the trick to this problem is recognizing that you only need 2 points to define a square, right? Because if you have a singular point, essentially, and you have another point, you can ask yourself, okay, if this is x1, y1, x1, y2, then the remaining points for the square will be x1, y2, as well as x2, y1, right? So if you have x1, y1, and x2, y2, any 2 points, you can see if it forms a square by getting the 2 remaining corner squares, right? That's kind of a nice little trick with squares. So what I did is essentially is like I have a hash map here that will map points to frequencies, right? Because here they say like, duplicate points are allowed, and if you like, you have a duplicate point somewhere and so on, and it's able to count twice, right? And the point is essentially whenever you add a point, you should be able to add a point, and then whenever you this count function, whenever it'll give you a point, and essentially you want to ask yourself how many squares can I form using this point, right? And if there's like if we could form a square with another point, and there's like 2 of that point, then that counts as like 2 valid squares, right? So that's kind of the idea. So that's why I have point to frequency mappings, not just like what points I have. So here, whenever I add something, I'll grab that point as a tuple, so it's hashable, and then put that inside my dictionary, and like I'll get its value 0 by default if it doesn't yet exist in the dictionary, and then add 1 to it, right? D.get of point or comma 0 will essentially make it 0 if point is not yet in the dictionary. Otherwise, grab the value at key point inside the dictionary, right? In the case, we'll just add 1, and there we go, right? So that's how we do it for add. Then for count, essentially what we'll do is like, okay, point, we're given a point, we'll do, okay, point of x, point of y is equal to point, right? Then we're going to loop through every single point that we currently have in our dictionary, right? We're going to ignore if x comma y in our dictionary is equal to like the current point that we're looking at. Obviously, we don't want to look with the same point and so on, so we're going to ignore that case, right? We don't want to think of it as a 0 by 0 square, where it's like, okay, the point is all 4 corners of the square, so that's not allowed, right? So obviously you'll overcount stuff like that. So we'll just, in the case where it's like, for every single point inside of the dictionary, except yourself, right? So if you're your own point, just continue. Otherwise, what we're gonna say is like, okay, the reason why this problem took me a little longer than usual is because I failed to recognize like, okay, only add stuff if stuff are squares, right? You don't want to detect rectangles. You want to detect squares. So if the absolute value of x minus point x and y minus point y are not the same, then we don't have a square. We might have a rectangle at play, but we do not have a square. So first of all, they need to be equal, right? The difference in the x's need to match the difference in the y's in order for this to be a square. So only add stuff to my result if the difference in x's is the same as the difference in y's, in which case it can be a square, right? Otherwise, I'll be like, okay, let's get the frequency of the point xy, right? So here we're querying for the point with point x and point y, right? And here for every single other point, we'll say, okay, let's grab the frequency of that point and multiply it by the frequency of point x comma y, right? So if you think of point x, point y as x1, y1, and x, y as like x2, y2, that's like essentially that's where you get your x1, y2, and x2, y1, right? So here's like we have point x, point y, x and y. So here we'll do the point x and y as well as x and point y combinations, right? Those are the 2 remaining points of the square, right? And we'll get the frequencies of those as well and multiply them all. Note that if a point doesn't exist, I'll do self.d.get at that point, right? And 0 by default. So if one of the points don't exist and are missing, then I have 0 squares in total, right? But that's not to worry because I'll be multiplying by 0. 0 multiplied by anything is just 0, right? So if I'm missing just even one of these 2 points, I'll be multiplying by 0 and I'll have no squares, right? Otherwise, it's like, okay, if I have 2 of this point, 3 of this point, and 4 of this point, that's like, okay, I have 4 times 3 times 2 possible squares using these coordinates because those are the frequency of those points using this point, right? So that's why I multiply these values together, right? So if it is indeed a potential square because the difference in x is the same as the difference in y, then I'll essentially multiply by the frequency x and y. Obviously, I know I have a value in d because I'm looping through every x to y inside of d. Otherwise, for these points may or may not exist. So I'll essentially get their value if they exist. Otherwise, default is 0, right? So if either of these 2 points are missing, then I know, hey, I cannot form a square, but 0 times anything is 0, so there we go. We correctly add stuff, right? Otherwise, if those exist, like, get their frequencies and so on, and then multiply them all because that will be the number of squares valid using those coordinates, right? And then again, we do that for every single xy that is in our dictionary, which maps all the current points that we have in their frequencies. And then once we've done that, once we've looped through all those points and added res for every single one, we'll just return that result, and there we go, bada bing, bada boom, we have the count, and that is essentially how I was able to solve that problem. And so hopefully that solution makes sense. And so as always, let's make sure that we come over here and check off the fact that we did this problem. And there we go. We're completely done with the math and geometry topic. We're at 99 out of 101 LeetCode medium problems solved. All that remains is 2 more bit manipulation problems that we'll be doing starting in the very next video. But otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I would highly appreciate if you left a like or a comment. But otherwise, I'll catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.